Okay, so now the fun begins. Now that you know how to use the periodic table and you know how to look at one square on the periodic table at one element and try to figure out all of the element's parts and what an atom would look like and all that, now we're going to dig in and find out more about the elements. So as an entire team, we're going to make one periodic table of the elements, and each one of you are going to be responsible for one little tiny book that's going to be displayed on our periodic table. So what we're looking at here is the title page, and that's why it's pretty blank. You know, the only thing that's required on it is your name and your block. But then I also want you to just copy the square from the periodic table. So for example, maybe you were assigned titanium, so you would just copy this square. Now, that's great. You can go ahead and you can do this today, and I'll just kind of show you, what it would look like. You'd put like 22. Whoops, that's WW. 22 at the top because that's its number, and then TI because that's it, etc. Okay, and so you copy all the stuff from the square on the periodic table. Now, the thing is, I would stop there for today. I would do the atomic number, its atomic symbol, the element name, and its atomic mass. And then don't decorate the front right now. Save the decorating for later when you know more about this element, and move on to the next page. This page, I think you're all going to feel pretty comfortable with. You all know how to figure out how many protons, neutrons, and electrons there are for any element by looking at the periodic table. And if you forget, just look back at previous resources. That's no problem. A newish word here is valence electrons. And just to remind you, valence electrons are the ones that are in the outermost shell. So you could look back at the previous page at the square, and the square on the periodic table, oftentimes in the upper right corner, there's a list of numbers. It'll say like 2, 8, 3. And the bottom number, that's the number of valence electrons, the ones in the outermost shell. You could obviously also use TED. Look up your element and look at the the number furthest to the right, and that tells you how many electrons are in the outermost shell. The electron dot diagram, we have not done that yet, and we're going to do that. I believe we'll do that all together tomorrow. So skip the electron dot diagram for now, and I'm going to just write. So the first thing to do on this group is to identify what family your element is in. And so remember, those are the vertical columns generally. Using ptable.com, it's color-coded, so that's kind of helpful. So family 1, hydrogen down to francium, those are all going to be in the same family. And if you look off to sort of the middle top, there's a color coding, and it tells you what that family is called. So those are called alkali metals. Notice hydrogen is not considered an alkali metal because it's really, really different than the rest. Then all the ones that are sort of like a mustard yellow color, those would all be in the alkaline earth metals family. So that's what you would write for my element is A. All the ones that are red, those are all considered transition metals. That's what you would write for that. Now, when you get through to groups 13 to 18, that's when I would recommend that you come down to this site, which I'm going to try to expand a bit, the Royal Society of Chemistry site. And so when you get to group 13, which is the boron group, you can click where it says groups, you click 13, and it highlights it, and it gives you a little blurb. Group 13 is the boron group, so that's what you would write. My element is a boron group, I guess is what you would write. And for 14, you would write my element is a part of the carbon group or whatever. All the way over to 18, which my element is a noble gas. All right, next, you're going to try to figure out what your element is at room temperature. And that's because depending on the temperature, any element can be a solid, a liquid, or a gas. If you add enough heat to even gold, it will vaporize and turn into a gas. So this is another good use of this table. I'm just going to refresh this so we can kind of go back to the normal view. And let's say that you are assigned strontium, SR. You click on it and it brings you to this page, and it tells you the melting point and the freezing point, first of all, so check that out. Please write down the melting point and freezing point in degrees Celsius, okay? We're not going to look at, we can look at Fahrenheit, and we can look at this other temperature scale called Kelvin, but I want you to report it in degrees Celsius. Melting and freezing point is obviously when it changes from solid to liquid or liquid to solid, and boiling or condensation point is that point where it would transition between a liquid and a gas. You can also find when it was discovered, if it's something that was actually discovered and not something we've just known through human history, like iron or whatever. So this one was discovered in 1790, and it even tells who it was discovered by. Some of your elements may not have that information. Now, as far as figuring out what it is at room temperature, what phase it's in at room temperature, you can play around with the temperature a little bit, and I'm doing that up here. I'm going to change the temperature to about 20 degrees Celsius. 20 degrees Celsius is what we would call room temperature, whatever, 21 degrees Celsius, that's fine. And when you play around with that, you see that we have these different colors lighting up now. And I would find strontium number 38. Whoops, I just clicked the wrong one. Strontium number 38. And it's light blue, so that would be a solid at room temperature. So at room temperature, my element is a solid. Okay, we're getting there. Hopefully at this point you are comfortable with the RSC website. And for uses of your element, you will choose your element. Let's say, indium. That was the one that I was assigned. Okay, I go to indium. And this site is great because it gives you, all of this information at the top in little bullet point. But the stuff we're really kind of going to be mostly interested in are uses and properties. And you can just read through here. It's not a ton of reading. Read through the whole thing before you write anything down, because you want to pick out the things that are the most interesting. So for uses of your element, uses and properties, that would be really helpful. Video and podcast, that's also oftentimes really cool, because sometimes within the video, they'll give you some cool information. I haven't listened to the podcast, but that might be helpful too. So just kind of bullet point, few words, a blast of information. So uses of my element. It's used to combine with this other metal to make bike frames. I don't know, just something really cool. This, as you study this information about your element, and you're looking, again, like I said, under uses and properties, I'm going to choose another element just to show this. Let's say your element is radon. You go to uses and properties, but you should also look at history. And sometimes when you look at the history, that may tell you uses, but it also might help you with the next page. The next page is interesting facts about my element. So the uses of my element and interesting facts about my element, they're going to kind of cross over, and you're going to find information for both of those on this site. So just kind of be aware that you might be filling out page 3 and 4 at the same time from this site. I just wanted to show you this site also, chemicool.com. And again, there's a link to this on Google Classroom. This is a good site to get some quick facts about your element and what makes it kind of cool. So I'm going to pick on samarium, and it tells you, whatever, what it was discovered by, what it might be used by, where its symbol came from, when the name came from. So this can sometimes be helpful for interesting facts. Remember, like I said, interesting facts about my element, you'll use those previous to, you can use any of the online periodic tables, all of them. Please just don't Google interesting facts about samarium, because I have found websites that I trust and that are made by scientists. If you just Google something, you might end up with some weird fact that is not really a fact. And finally, this page, I feel like really confident that all of you will be able to handle this no problem. Just make sure that your Bohr model is really neat. So if yours has, say, 18 electrons in one of the shells, pair your electrons, or even just write 18E in the ring, and just make it as neat as possible so that it's easy for somebody to look at and understand what you're trying to show.